Hi, now we will see about the Hadoop distributed file processing system. So we know that Hadoop, it follows a master slave architecture. So the master node, it is responsible for assigning the various tasks to the slave nodes, and it also manages the resources and maintains the information, major informations. Whereas in slave nodes, it is responsible to perform the computation as well as the original storage. And this is the architecture which we saw already. We have three layers in Hadoop. One is the application layer, second one is the resource management layer, and third one is the storage layer. Now we will see about the third layer of Hadoop, which is HDFS. So before that, let us see what is a distributed file system. So a distributed file system, basically it allows the informations to store across multiple devices. It may be in a cluster format, and thereby allowing the multiple users to access the information. So if you see the difference between a local file system and a distributed file system, so here in local file system you have one storage available for a file, whereas here I have a file which is of 4 terabyte and in distributed format. So I will be having four different storage system which is available in different regions, and each storage will have a capacity of 1 terabyte. So this 4 terabyte information can be divided as 1 terabyte information. It can be stored across four different devices. So this is called a distributed file system. In Hadoop file system, it is a distributed file system which allows us to storage large data across the cluster, which is the same as your distributed file system. So here I have three questions arises whenever I have such a distributed file system. So the first question is, who is responsible for managing such a clustered distributed environment, right? Whereas second question is, who distributes the data across these clusters, and how the data has been accessed. So I have three different questions. So whenever I use a distributed file system, so we have an answer for that, which we can see it in the forthcoming slide. So Hadoop distributed file system, it is a Java based file system which is used for storing a large amount of structured, unstructured, and the data ranges may be from gigabytes to petabytes, because it supports a larger data storage information across a cluster of commodity hardware. It is the most reliable storage as on date. Because why I'm calling it as a reliable, so it is whenever a failure happens, it can restore back, because the informations are being shared among many other devices. It is in a distributed form. So whenever a device goes down, so the other devices can help us to retrieve back the information. That's why we call it as a reliable storage. So on the previous slide, I said about three different questions, like who is sharing the information, who is managing the information, and how the access to such informations are done. So all the questions are answered by using a device called master node. So in HDFS architecture, this is also supporting a master slave architecture, and here we call it as a name node and a data node. Data node, it is present at the slave nodes, whereas the name node, it is present at the master node. So the data are being distributed to all the slave nodes using the master node, and the retrieve is also done by the master node, and the master node is the one which manages the informations across these slave nodes. So name node, so it is a master daemon. It maintains and manages all the data nodes, and it receives heartbeat and the log reports from all the data nodes at regular basis, and it records the meta information. Whereas the data node, these are the slave daemons. It actually stores the information, and it serves the read and write request from the clients. All the processing and the computations are done at the slave level. So here I have a concept called data blocks. So the complete the file or complete data has to be divided into certain blocks of information, and these blocks of information has to be stored across the slave nodes. That is the concept of an HDFS. So here the each file is stored on a HDFS as block. So the default size of each block is 128 MB in a Hadoop 2.0 version, whereas previously it was 64 MB for Hadoop 1.0. So suppose if I have a file which whose storage is 380 MB, so now the division of blocks is like 128 MB in block 1, that is one slave node. The other slave node will have again 128. So 128 plus 128, it is 256. Remaining data is 124. It is stored in the third block. So here you can see the master node, which is the original file, which is having the capacity as 380 MB. Now it is divided into three different blocks. So the first block, that is the first data node, slave node, which is having 128 MB information. The second slave node will have 128 MB information, and the rest of the information, which is 124 MB, it has been stored in the next slave node. So we have one question across here. So in case of a node failure, what will happen? For example, I have this third slave which is of 124 MB has a failure. So what will happen to the information which is available in that 124 MB? So scenario is one of the data nodes got crashed containing the data blocks. So the solution is we have a property called replication. So that means each and every node, since it is a distributed environment, so each and every node in the in the network will have a copy of all other nodes. For example, if you see here, the first block, it is actually shaded in 128 MB. So this is the first data node which is having 128 MB. It has its replication in the other data node also. Similarly, this 128 MB, which is shaded in green color, it is present in itself as well as with the other data node also. Similarly, this 124 MB, which is shaded in blue color, which is actually got crashed. So one of its copy is already stored in the data node number 2 and the other data node also. So this third data node is actually depends on the division of number of blocks it will be available. So this data blocks can have any of its replication, any of this first part or second part or third part. So in our scenario, this fourth data node, it is actually having a copy of the first data node and the third data node. So whenever this third data node falls in the crashes or it got crashed, so it can be retrieved from the data node 2 and as well as from the data node 4. So each data blocks are replicated thrice by default. So here I have a factor called replication factor, that is the same informations will be replicated thrice. That means one itself as well as with the two more blocks will have a copy of this information. So each data block are replicated thrice and are distributed across the different data nodes. So what is this benefits of replication? So you have a fault tolerance, reliability, and information is available all the time, and the network bandwidth is also utilized fully. So thereby you will have the higher throughput. So this is how the replication occurs. You have the file and you have three different blocks and the replication of blocks occurs. So here I have a scenario, so where I have a file with this 100 TB and which is being given to the master node. So the master node actually it is dividing the data into three different blocks, and I have 10 number of slave nodes. So this three informations will be stored in any format in this 10 number of nodes. That's the beauty of this distributed file system. So I cannot say which slave node is actually having the which informations. It can be shared among any slave node. So whenever a query has been given by the client for retrieval, so this master node would send that information to that slave node, and whoever is holding that particular data block will reply back to the master node. So that is how the retrieval of information happens. So here the explanation of the slide. So let us assume that 100 TB file is inserted, and then the master node will first divide the file into blocks of 10 TB. Okay, so these blocks are stored across different data nodes, and these slave nodes replicate the blocks among themselves, and the information of such blocks are sent to the master. So default replication factor is 3, meaning so each block will have 3 replicas, one itself, and the remainings are stored in 2 different slave nodes. And this number of replication factor can be increased or decreased by using this hdfs.site.xml. Okay, and we can edit its configuration here. So this is all about the Hadoop distributed file system. Thank you.